All right, so this chapter is called Exponential Functions, I think. And so we're actually starting at exponential functions. Exponential functions, the root of exponential is exponent. So hint, hint, hint. Your variables will have exponents. All right, so this is where your notes start. Make sure you put everything in the way it's supposed to be before you start. And make sure you do what you're supposed to do. Pause when you're supposed to pause. Do it on your own to see if you can solve the problems as you're working on it. Look at it and think about it as you're working. Exponential function is a function in the form of y equals ab to the x power. See, exponents. A cannot be 0 because then y would be equal to 0, which is not an exponential function, it is a linear function. B cannot be 1 because 1 to any power is still 1, and you would still have a linear function. It would be a straight line, horizontal line. And B has to be greater than 0. Exponential functions are nonlinear. They are not lines. Changes are made by equal factors. Remember, a factor, numbers that you multiply together over equal intervals. So as y increases by the same amount, y will increase by the same factor. So x's are going to be like plus 1, plus 1, plus 1, plus 1. Whereas your y's are going to be times something. Times 2, times 2, times 2, times 2. So you're multiplying by the same amount. If you're multiplying by a number greater than 1, it's exponential growth because it'll get bigger from left to right. If you multiply by a number less than 1, which is the same as dividing, that's called exponential decay because your numbers are getting smaller and smaller and smaller. That's the next two sections, exponential growth and exponential decay. Linear functions have a constant rate of change. So you're adding or subtracting by the same number each time. Your x to x to x to x is always plus 1, plus 1, plus 1, plus 1. Y to y to y to y would be like plus 2, plus 2, plus 2. It's always adding the same amount. So that's the difference between exponential function and linear function. Y equals ab to the x power, your exponential function equation. A is the y-intercept. So this constant that does not have the exponent, that's being multiplied by this constant with an exponent, that A is your y-intercept. B is the factor the function increases. So if it's your y value is times 2, times 2, times 2, times 2, if you're looking at a table of values, your B is your 2, because that's what it's increasing by each time. All right, so the question is, does it represent a linear function or exponential function? So you have to look at your x's and then your y's. How does your x increase each time? Plus 1, plus 1, plus 1. How does your y increase each time? Plus 2, plus 2, plus 2. As your x increases, your y increases by adding, therefore it is linear. X increases, plus 1, y increases, plus 2. If we were doing slope, it would be slope is 2. So that's linear. Let's look at this table of values. X increases by 1 each time. Your y is increasing each time 4 to 8, 8 to 16, 16 to 32, times 2. As your x is increasing, your y is increasing by a factor because it's multiplication. So this is exponential function. If we were to write this exponential function as an equation, remember it's y equals ab to the x power. A is your y-intercept. B is your factor. What is your y-intercept? Your y-intercept is your y value when x is 0. Your y-intercept is 4. B, the factor that it's increasing, is 2. So this equation would be y equals 4 times 2 to the x power. You cannot simplify those. You have to leave it like that. It is not 8 to the x power. It's y equals 4 times 2 to the x power. Okay, so if your instructions are to evaluate each function for the given value of x, this is your function. It is an exponential function because we can see it's being multiplied each time. Your a is -2, which means that is your y-intercept if you are graphing. Your b is 5. That means each time y is times 5, times 5, times 5, times 5. Okay, they want to evaluate if x is 3. So you substitute 3 in for your variable. Y equals -2 times 5 to the 3rd power. Order of operations, you have to do your exponents first. So, using your calculator, 5 to the 3rd power is 125. Y equals -2 times 125. Y equals 0, 5, 2, -250. You have now evaluated it if x equals 3. Whoops. Okay, to graph, we know that our y-intercept, what should your y-intercept be? This is your equation, what should your y-intercept be? There is no a, so if there is no a number before my 2 to the x power, it's 1. Your y-intercept is 1. So we know what that's going to look like. After that, we don't know. So we have to make a table of values. When in doubt, make a table of values. Okay. My graph goes from -6 to +6. I don't want to put them all right next to each other because I need more. I actually need more than my normal 3. Okay, I'm going to go -4, -2, 0, +2, and 4. These are arbitrary numbers that I'm just choosing, but I want to spread it out a little bit more. So, y equals 2 to the -4 power. It is a negative number, so I know it's y over 2 to the 4th power. I'm going to use my calculator. 1 over 2 to the 4th power. 2 times 2 is 4, 1 to the 6 to 1/16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So when x is -4, 1/16 is my y value, so I'll graph it. Now I'm going to move to this one. You figure out what your y values are for the rest of them. Hit pause and figure out what they are on your own and graph them. Oh, it's off my chart, so I'm going to put it up there. So this looks like it's getting closer and closer and closer to 0, but will never reach 0. So I'm just going to draw my line like that. That's going to continue there, that's going to continue there, but never equals 0. There's my graph. My y-intercept is 1. I proved it here. I am multiplying by 2 each time. Whoop! Oh, shoot, forgot about this one. Okay, describe the domain and range. So my domain are my x values. So I look to the right, I look to the left, can I make a conclusion? I can go to the right forever. I can go to the left forever, so it's -infinity to +infinity, or all real numbers. My range is my y values. So I look up, it goes up forever. I look down, it does not go down forever. So it must be the lowest value it can be, and it's not 0, but it's everything above 0. So my range, y is greater than 0. It is not equal to 0. Y is greater than 0. That's your domain and your range. All right. Next one. What do? I don't know. I'm going to do a table of values. X, my equation, y. So let's see here. I'm going to choose -3, -1, 0, 1, and 3. So y equals 2 to the -3rd power plus 3. That is 1 over 2 to the 3rd power plus 3. 2 to the 3rd power is 8. 1/8 plus 3 is 3 and 1/8. Okay, now -1. So 2 to the -1 power plus 3, that is 1/2 plus 3, 3 and 1/2. 0, 2 to the 0 power plus 3, 2 to the 0 power is 1, 1 plus 3 is 4. See why those exponent rules are so important? Okay, 2 to the 1st power plus 3, 2 to the 1st power is 2, 2 plus 3 is 5. 2 to the 3rd power plus 3, 2 to the 3rd power is 8, 8 plus 3 is 11. So now I'm going to start graphing. -3 and 3 and 1/8, -1 and 3 1/2, 0 and 4, 1 and 5, 3 and 11. I can tell that it's getting closer and closer and closer to 3, but it will never hit 3 because of the way these fractions are going. So that's my graph. My domain are your x values. How far to the right can it go? Infinity. How far to the left can it go? -infinity. Therefore, your domain is all real numbers. What about your range? How high can it go? Infinity. How low can it go? I see that it's getting closer and closer and closer to 3. It's never going to hit 3. So my range is y is greater than 3. All right. Isaac and Gabe at chess, hopefully I gave you a new page. It has new graphs. When I was working on this before videotaping it, I didn't like what I had as a graph, so I changed it. All right. K translates the graph up or down. Y equals A times B to the x power. That's your basic exponential equation. If you add K or subtract K, which would be adding a negative K, is translated up or down. So if K is greater than 1, it goes up, however many that number is. If K is less than 1, it goes down, however that number is. So if we look back at this one, this is plus 3. Our normal one gets y equals 2 to the x power. Got closer and closer and closer to y equals 0, the x-axis. So plus 3 means I'm going up 3, and it gets closer and closer to 3. So that K value tells you how much up or down it is from the axis. All right. If given a graph, look at the y-intercept. The y-intercept of the translated graph is, so x is going to be -2, -1, 0, 1, 2. So if x is -2, I have 1 over 0.25 squared minus 1. And I need to get my calculator for that. 0.25 times 0.25 equals 1 divided by 0.0625. Oh, 16 minus 1 is 15. So -2, 15 is way up here. -1 So let's see here. 1 over 0.25 minus 1. 1 divided by 0.25 equals 4 minus 1. That is 3. Negative 1, 1, 2, 3. So that's here. Zero. That is 1 minus 1, which is 0. Oh, I guess I could be doing it here too. It's the same graph, so we're comparing it to this one. 1, 2, 3. Alright, if x is 1, 0.25 minus 1, which is negative 0.75. 1, 0.75, we'll still there. Squared, 0.25 squared minus 1. I'm going to use my calculator for that one again. 0.25 times 0.25 equals minus 1 equals negative 0.9375. Negative 0.9375. So 0.9375. So we can tell we're getting closer and closer to negative 1, right? Which is good because that is what that means. It went down 1. This is my graph. This is my graph. Alright. So I have to compare red to blue in order to find my k. I'm going to look at my y-intercept. My y-intercept of this one is 0. My y-intercept of this blue one is positive 3. So it is a shift of 4. 3. It's a shift of 3 up. So my k is going to be 3 because it was a shift of 3 up. Now look at this one. From your red to your blue, look at your y-intercepts because you know exactly where those are. This y-intercept is 0. This y-intercept is negative 2. So it is a shift of 2 down. So k equals negative 2. All right. Already touched on this, already talked about it. That is your generic form of your equation in exponential function. Y equals a, b to the x power. A is the y-intercept. B is the factor of the function increases. Use the table below to write an equation. So your x is increasing the same amount each time. Your y is increasing what? Times 5. Times 5. Times 5. Times 5. All right. So A is your y-intercept. It happens when x equals 0. So A is 2. B is the factor that your y increases each time. B is 5. So your equation is y equals 2 times 5 to the x power. All right. The graph represents bacteria population y after x days. Okay, let's see. Oops. Y is the bacteria population, the amount of bacteria that you have, so the population of bacteria, after X amount of days. It's an exponential function. Use a table of values. Okay, so X, Y. For each point, that's nice that they gave us the points. X is 0, Y is 3. My next one, X is 1, Y is 12. My next one, X is 2, Y is 48. I'll do 3, but I'm not going to write 4 because I'm running out of room. Because we need to find, remember we're doing y equals a, b to the x power. A is your y-intercept. Y-intercept is your y value when x is 0. So a equals 3, because we know that right there. Your b is what this is increasing by. So what's happening each time we go from your x, it's times 4. So your b is 4. So writing your equation, y equals a, your y-intercept is 3, times b, your b value is 4, to the x power. So the number of bacteria you have is equal to 3 times 4. 4 is raised to however many days we're talking. Because that's what x is. X is how many days. And this is 2 parts. It's asking you first for 12 hours, and then after 5 days. X is in days. So this needs to be in days. 12 hours is how much of a day? Half a day. So I'm putting it in my equation. The number of bacteria is what they want to find. So we're finding the population is equal to 3 times 4 raised to the number of days. This is to a half a day. We have an exponent that is a fraction. We know how to do that. Y equals 3 times square root of 4. Because that exponent only goes to this 4, not to this 3. 3 times square root of 4 is 2, so 3 times 2 is 6. So your population is 6 bacteria. After 5 days, so 5 is going to be x, because x is the number of days. So substitute it in. Y equals 3 times 4 to the 5th power. 4 to the 5th power, I have no idea what it is. I don't have my calculator with me. There we go. 4 to the 5th power, 1024, 1024 times 3. 1024 times 3 is 3072. And of course I'd have to write this in sentences. After 12 hours, there are 6 bacteria. After 5 days, there are 3,072 bacteria. It might be bacterium. I have no idea. Science isn't my thing. Homework. 16 problems. When asked to create a graph, use your graphing calculator to check. So they're in the back if you need to take whichever one is yours. Hopefully they've been plugged in. Hopefully they're charged. That's just to check it.